So good evening everyone, and here we are probably on the last day for reflection. Your reflection will be over by this class. In the last class, if I remember correctly, we were discussing questions which were based on reflection from two or more than two mirrors, and I told you that the maximum that you can get in a JEE advanced ka paper, I'm not talking about JEE Mains, the maximum question, the most difficult question that you can get is reflection from two mirrors. This will again come when you'll have lens and a mirror combined, and that time it becomes more interesting. This year JEE Advanced had two lenses combined. Very easy. We'll also be solving today the question that appeared in JEE Advance of this year. So don't worry, just keep listening to this lecture. I'm just slightly changing the pattern, and I saw this very wonderful question, and I wanted to discuss it with you. Sometimes I have this hunch, this denomination that these type of question can come, and I just saw this question and I thought, now this is the type of question that you can expect in the next year. Good luck if that's so. So this is the question that coming up to you. It's a very simple short question, can come in JEE Main as well as JEE Advanced. The angle the sun subtends is theta at the pole of a concave mirror. What is this? Theta at the concave mirror. The focal length of the concave mirror is given as f. What is the diameter of the image formed by the mirror? We're taking the image of the sun. Now, this is the type of question that bamboozles everyone. I hope it does not bamboozle you. So, you'll have 1 minute to do this. It's pretty simple. 1 minute to do this. What will be the angle subtended by the image of the sun? So I'm looking at the sun through a concave mirror. Where is the how much is the diameter of the image formed by it? Now sometimes what happens is the question is asked in a slightly different way, and that puzzles us all. Normally the question that you will expect is find out the value of u, find out the value of v, but here they have asked you to find out the value of the diameter of the image. Yes, how will you do it? I see no online student. The other class, can you hear me better? The class that I cannot see.
Sir.
Yes, you can hear me, right? You can see me,
Yes,
obviously,
sir.
right?
Yes, sir.
Well done, sir. So, do we have an answer, sir? How will you do it? Now, I want you to solve this question on your own, but to help you out, I will give you this small diagram, which I should make it bigger so that you can see it. Right. This is the diagram, and once you have a look at this diagram, you should be able to tell me what is the answer for this question. What you see are rays coming from the sun, and then the rays get reflected and you have an image, and you see this angle theta. This is the angle theta that the sun subtends at the concave mirror. The focal length of the mirror is given as f. The first thing that should come to your mind is, where is the image going to be formed? Where is the image of the sun going to be formed, bacha? Tell me. Where is the image of the sun going to be formed? Where is sun? Sun is very far. Far means infinity, yes or no?
On the focus, sir.
So where is the image going to be formed?
Focus.
It is going to be formed at the focus. You have to just tell me the diameter of this image. So from here to here, the distance, as you can see, is f. And if I draw this distance is the diameter d of the image. Yes or no? Do we understand this?
Yes, sir.
Sir.
Then you should tell me the answer then. And the answer is, my dear friends, Remember, this theta is going to be small. Yes, beta. What is the answer?
2f sin theta.
2f sine theta. No. Try again. Well, you're getting there.
2f theta.
2f theta. 2f theta. Slight mistake. See, remember, there is nothing that I have not told you that will help you in solving the question. See, we have done this, yes or no? Rays which are coming from infinity but not parallel. This question is similar to the one that I just showed you, yes or no?
Yes, sir.
And if you look closely, remember the total angle is theta here. So 2 does not come, my dear friend. And the value of this diameter D, again wrong. The value of this diameter D is simply F multiplied by theta. Do we get this, bacha?
Yes, sir.
Or you can write, if you want to, if you look at this triangle, sort of a right angle triangle, and if I will draw that right angle triangle, when I draw that right angle triangle, then probably this will make sense. Remember, understand this angle is theta? Everyone understands this, bacha? This distance is your D. Do you see this? And this distance is your F. Everyone gets me? Yes or no?
Yes,
This theta
sir.
is very small, so I can write D as F tan theta, or simply I can write D as F theta because theta is very, very small. Do we understand this?
Yes, sir.
Everyone got this? Can I have raise hands from everyone that we understand this, how this is done? So remember this. These are the type of questions that can appear in your examination hall. So don't get bamboozled by such questions. Can I move ahead? And I will move to the heading of today's class. And the heading of today's class is velocity of object and velocity of image. Velocity of object and velocity of image. We have done the same thing in plane mirrors, yes or no? Do you remember we had done the same thing in plane mirrors, yes or no?
Yes, sir.
We are going to do the same thing here in this case also, where the object is going to move, and we will discuss all sorts of things here. And we will take the example of a concave mirror because it is easier to understand. When it is a concave mirror, it is easier to draw as well. So this is my concave mirror. Okay. Now there are two things that are going to be possible. So we will do it case by case. Case number A, velocity of object is perpendicular to PA. Do we understand the meaning of this? Do you understand the meaning of this? Yes or no? No, yes. Velocity of O is perpendicular to P.
Yes,
Do you understand this?
Yes, sir.
So this object is going to move like this. The object is going to move perpendicular to the principal axis. Do you see the principal axis here?
Yes, sir.
The object is going to move perpendicular to the principal axis. Now, when the object is going to move perpendicular to the principal axis, and here remember what we are imagining is that this mirror is stationary, because if the mirror starts to move, remember we had moved the mirror in the case of a plane mirror. In the case of a plane mirror, in the question that we discussed, both the object and the mirror were moving, yes or no?
Yes, sir.
And I probably gave you questions based on that plane mirror curve motion in the last paper. Yes or no?
Yes, sir.
Well,
Yes,
in
sir.
case of a concave or a convex mirror, normally we don't make a question where the mirror moves, because then it becomes very complicated and it becomes more calculative. Those type of questions don't come. So in normal cases, the mirror is going to remain stationary and the object is going to move. There are two ways in which this object can move. The first way is this object can move perpendicular to the principal axis. Now, how are we going to find the velocity of the image in this case? Well, remember, whenever we solve any question in this optics, we always try to take references. Now, let us see. This is u. Do you understand the meaning of u? U is not the initial velocity. What is u here?
Object distance from the mirror.
Object distance from the mirror. Well done. Let us imagine this is the object. This object will create an image. Let us say that the image is here. So let me write O here and let me write I here. And I'm taking them as point objects. And let us assume that the image is moving like this. Just, it can move the other way as well. Let us imagine that it is moving this way. Now, what is this? This will be V, yes or no? Do we understand this?
Yes.
This V is not the velocity. What is this V?
Image distance from
Image
the
distance.
mirror.
Now, how will I find a relation between the velocity of the object and the velocity of the image? Now, I can do a big proof on that, but I will tell you that proof in very short. And if you remember a question where I always try to relate things with what we have done previously, so that you understand that we are not doing anything new, and everything that we are doing has already been done. Do you remember this question where instead of the object placed on the principal axis, the object was placed above principal axis? Yes or no?
Yes, sir.
And then it was asked, find out the position of the image. You find out the value of V, then you use the formula for magnification and find out the height of the image. The height of the image was nothing but the position of the point object from the principal axis. Yes or no?
Yes, sir.
Now, similarly, I can apply the similar principle over here and find out the velocity of the image. Now, how am I going to do that? I'm going to do it in very short. I'm assuming that this is a point object, and let us say this is HO. Do we understand the meaning of HO?
Height of the object.
Height of the
Object.
shabash, my bacho. Do you understand what is this HI?
Height of the image.
That's it. If we understand this, we understand everything. So I can write the height of the image divided by the height of the object will be equal to magnification. That will be equal to minus V by U. Yes or no?
Yes, sir.
Done. Then we are done. So I can write height of the image as M times the height of the object. Yes or no?
Yes, sir.
I can differentiate this equation with respect to time. If I differentiate this equation with respect to time, I will get the rate of change of height of the image will be equal to M times, because M is constant, V and U are constant. The particle is going to move perpendicular to the axis. So M times dHO by dt. Do we understand this? Yes or no?
Yes.
I have just differentiated both sides. Do we understand this? Yes or
Yes,
no?
sir.
No, yes. But that gives me the relation velocity of the image will be M times velocity of the object, where M stands for what, my dear friends? M stands for what?
Magnification.
M stands for the magnification. I can write this formula in a different way. Magnification is minus V by U. Yes or no? No or yes?
Yes, sir.
So I can write velocity of image as minus V by U times velocity of the object. Do we understand this?
Yes,
So
sir.
this will give me the relation between velocity of the object and velocity of the image when the object is moving how? When the object is moving perpendicular to the principal axis. Can I have raised hands from everyone that we understand this? You don't have to understand how it is derived. Why I am doing this? Because there may be a question where you might be required to find dH or dV, or the rate of change of height, or the rate of change of height of the image. Then you can use the same thing whether they ask you the rate of change of height of the image or they ask you the velocity of the image. They are referring to the same thing. Do we understand this? Yes or no?
Yes,
Sir,
sir.
differentiation, how did you do, sir?
Yeah, beta?
How did we do that differentiation, sir?
Well, we had covered it in the 11th standard. Yes or no? Well,
How
don't
did
worry.
we get VI, sir?
When you differentiate distance with time or position with time, you get velocity. Just remember this, okay?
Okay, sir.
So again, as I told you, you might not understand, you might not remember this entire thing that I am going to put in a block. You just have to remember what is there in the yellow. Can you remember that? That is what that is going to matter. Yes or no? No or yes?
Yes, sir.
Can you remember this? When the velocity of the object is perpendicular to the principal axis, velocity of image will be minus V by U times velocity of object, or I can write it as M times velocity of the object. Can you remember this?
Sir, is it the case of differentiating position or
We are
something
differentiating position, beta. Yes.
that what
H2.
gives the velocity, right, sir?
Yes, beta. Sorry. Tell me what you want to say. Object is changing its position.
Clear,
We are
sir,
just,
clear.
object is changing its position. We are just finding the rate of change of position. Nothing else. That is the velocity. Yes or no? Anyone has
Sir.
noted this down? Yes or no? No or yes?
No, sir.
Please note it down. Why are you waiting? For what are you waiting, my dear friends? Please let me know once you are done so that I can move on and do case number B. And what would be case number B? Case number B would be the velocities along the principal axis. Can I move on?
Yes, sir.
Yes, sir. Then we move on to case number B. Case number B, velocity of the object is parallel to your principal axis. I hope everyone is noting it down. This is my concave mirror. This is my legendary principal axis. And let us say this is my object O. And let us assume that it is moving like this. Do we understand this? Yes or no? Let us say that this object distance is U. Are we getting my point? Are we getting the diagram? Yes or no? No or yes?
Yes, sir.
Yes, sir.
This is my image, my dear friends. Let us imagine that the image is moving like this. The distance of the image from the mirror is V. I hope you understand this. And this gentleman is not moving and the focal length is F. Now here, U is changing with time. Do you get this? Yes or no?
Yes, sir.
V is changing with time. I need to find out du by dt and dv by dt. Yes or no? No or yes? Here u and v are changing. I have to find out the rate of change of u and the rate of change of v. How will I find it out? Very simple. I will use the mirror formula. 1 by u plus 1 by v is 1 by f. Do we remember this formula? Yes or no? No or yes? If you remember this formula, I am going to differentiate this formula once, and I'll not go into the derivative part because that is class of maths and we are not into maths. What I will get will be an equation like this: dv by dt will be equal to minus v square by u square into du by dt. It is achieved by differentiating equation number 1, and again I will not get into the derivative part. Do we understand this? Derivative part you can do in the class of differentiation, and I hope you have done this. Now this dv by dt is the velocity of the image, so the formula I get is velocity of image v square by u square is m square, so you can write it like this: minus v square by u square minus v square by u square times velocity of the object. This is the first way in which you can write it, the yellow one, or you can write the same thing in a different way. Velocity of the image is minus m square times v by u ka square is m ka square, velocity of the object. So these are the two formulae that we have derived for velocity of image and the velocity of object, how they are related in two different cases: when the particle or the object is moving perpendicular to the principal axis and when the object is moving parallel to the principal axis. Again, what is important here is that you remember this formula that comes, and the case in which this formula comes. Do we understand this?
Yes, sir.
Please note down this formula. If you have any doubts, ask. Else I will give you a question and then we will try to solve the question that came in this year JEE Advanced and see whether we are good enough to do it, which I think we are.
Noted, sir. We completed noting, sir.
Yes, beta?
Yes, sir.
You have completed this?
Yes, sir.
Okay. Shall I move on and give you a question? You have noted this down, everyone?
Done, sir.
Then is the time that I present a question for you. Anyone ready for the question? An object is placed at a distance of 20 meters from a concave mirror of focal length f is equal to 5 meters. The object is moving with a velocity of 2 meter per second. Find the velocity of image if case number 1, it is moving perpendicular to principal axis. Case number B, it is moving parallel to principal axis. Do we understand this question, everyone? Yes or no? No or yes?
Yes, sir.
Can I imagine? Can I hope that you can get the answer for this one?
Yes, sir.
Well done, sir. Then, sir, your time, sir, starts now, sir. And I hope you get me the answer, sir.
2/3 meter per second.
In which case? Case number A or case number B, my dear friend?
A.
How much?
2/3 meter per second.
Okay, what about case B, my dear friend?
Sir, 88.8 meter per second.
88.8. In second case or first case, my dear friend?
Second one, sir.
Second one 2/9 meter per second.
See, everyone is getting a different answer, my dear friends. Now remember, and always remember this. What?
A is 2/5 meter per second.
Okay. Anyone else with an answer?
Sir,
B 2/25.
2/9
Okay.
meter per second.
Remember, JEE is not a test of your skill. As I keep on telling you, JEE Main is a test of your speed. JEE Advanced is 70% a test of your speed, 30% your knowledge. This year's paper was probably 90% speed and 10% of your knowledge. See how you got to do it.
Say minus 3/50 meter per second.
Okay.
For A.
It's good that I'm getting so many answers. That means so many people are trying. That is what I want. It is moving perpendicular to principal axis. Let us first discuss this. Yes or no? No, yes? Okay. Now, when it's moving perpendicular to principal axis, my dear friend, what is the formula for velocity of image? Tell me. Fatafat.
Minus V/U into V0.
M
Velocity
V0.
of the object.
See, now that is what I say, hard work and smart hard work. Remember, you'll have to do hard work but smartly. Now, velocity of the image in first case, case number A, you can either find it out by minus V/U times V0, Now to find out this minus v by u, first you have to find the value of v. Yes or no? No, yes?
Yes, sir.
You will add another step in the question which is not required. Think smartly. Think smartly. Minus v by u was nothing but magnification m. Yes or no, my dear friend?
Yes, sir.
It's m times v naught. And I had given you the shortcut formula for m.
F by F minus U.
Yes, my dear. F upon f minus u. Put the formula in this equation. Stay happy. Don't have to calculate v. First we'll calculate v, then you will divide it by u, then again take the minus. Let's do this now. We'll get the answer straight away. Do we understand this? Yes or no? No, yes. F is 5. U is remember, you will have to use this formula with proper sign convention, my dear friends. If you don't use it with the proper sign convention, you will be lost. Now, can you tell me what is the answer, my dear friends? How much is that? Say. Arey, say.
2 by 3.
F is 2 by 3?
Please.
You are telling me the answer. So F is minus 5 divided by minus 5. U is minus 20 into V naught is 2. So minus 5 plus 20 is plus 15. Minus 5 divided by 15 is minus 1 by 3. Minus 1 by 3 into 2, and the answer that you are going to get is minus 2 by 3 meter per second. That means if the object is moving upwards, image will be moving downwards. Do we get this? Yes or no? No or yes? How many of you got this answer? Please raise your hands. Well done, sir. Well done, sir. Now, I've told you the trick to do this one. Then, my dear friends, you can straight away tell me the answer of the part B, sir. Please, sir, tell me, sir. Remember, JEE is not cleared in the examination hall. It is cleared here in the class. If you do it in the class correctly, well, everything is going to turn out so simple and so easy. Answer for the second one, my dear friends. And I wait for your answers. Tung, 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 tung. Yes, I'm waiting. And I'm not getting the answer.
Minus 2 by 9 meter per second.
Minus?
2 by 9 meter per second.
That is absolutely correct. That
Minus
is
2 by 9.
m square into V naught. We have already calculated the value of m. It is minus 1 by 3. So m square becomes plus 1 by 9. Again take a minus. So it's minus 1 by 9. So your answer is V naught, which is 2 with a minus by 9. Do we get this? Yes or no? No, yes. Yes or no? No, yes. How many of you got it? Please raise your hands like this. Do. Okay. Well done. Now the real challenge comes, my dear friends. And this is integer type question from this year's JEE. And when I say JEE, I mean JEE Advanced. Good luck. May God help you. Wait, this one. Remember, God is not going to help you. You have to help yourself, my dear friends. So this question comes. You might have to spend some time in reading this. Remember, this is 4-mark question because I think this is integer type. And the question is on your screens right now. And now you will say, sir, what, sir? An object and a concave mirror of a focal length 10 centimeters move along the principal axis. When you read the first line, you will say, "Sir, you did not teach us this. You said that the focal that the mirror will remain stationary. Yes or no?" And now, as soon as the question comes in JEE, the mirror starts to move. I told you, na? Yes, yes. Here, the mirror is stationary. Yes or no? But then I also told you, dung 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 dung. I am going back. See, I have a time machine. I can go back. 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 अरे कितना back? Back. 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 कितना back? More back. More back. More back. More back. More back. More back. Back, 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 back. Oh God, too much back. Back, 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 back. Here, back. This much back. Oh no, too much back.
Sir, your slide got stuck, sir.
No, I paused the screen. It got cut. This back, I had to bring you.
Okay, sir.
And it was like this, right? I am and OM. Do you understand the meaning of I am and OM? Image with respect to mirror and object with respect to mirror. Do we remember this? Image with respect to mirror and object with respect to mirror, my dear friends. And the question that I gave you was the object and the mirror, where the mirror was stationary. Now the mirror suddenly starts to move. So what difference will it make when the mirror starts to move? That is what you must think. I was going to tell you before attempting this question, but I thought that I'll give you as an exercise so that you apply a bit of your brains to find out. The problem that I gave you was with respect to the mirror was stationary. Now the mirror starts to move. An object and a concave mirror of focal length 10 centimeter move along the principal axis of the mirror with constant speeds. Wow. The object moves with speed v0, 15 meter per second towards the mirror with respect to the laboratory frame. Laboratory frame means ground frame. The distance between the object and the mirror at a given point is given by u. U is 30. The speed of the mirror is such that the image is instantaneously at rest in the laboratory frame, and the object forms a real image. What is the value of the velocity of the mirror? And the question passes on to you, my dear friends. This is the question. An object and a concave mirror of focal length 10 centimeters move along each other. It's move along the principal axis of the mirror with constant speed. The object moves with a velocity at 15 meters per second. The value of u is u, 30 centimeters. The image is instantaneously at rest with respect to the laboratory frame. The object forms a real image. What is the value of m? Velocity of the mirror. And you shall have 2 minutes for the wonderful time. Can I have an answer for this one? Two minutes is what you get, my dear friends. Yes, my dear friends. Anyone with an answer? See, if the mirror was stationary, you knew the answer straight away. But what if the mirror is not stationary? What changes do you think that you need to make in the revolutionary formula that I gave you? That is what you need to think. As soon as you get it, my dear friends, answer will come. Anyone with an answer? Okay, shall I do it? So, how do you do it? It's pretty simple. The only thing you have to understand is, when I talk about this velocity of the image, I have taken the distance of the image from the mirror itself, yes or no? And I have also taken the distance of the object from the mirror itself, yes or no? Can I have raised hand that everyone understand this? That is the only difference that I have to make if the mirror also starts to move, is that I have to write this formula in this way: velocity of the image with respect to mirror will be equal to minus m square times velocity of the object with respect to mirror. Do we understand this? That's it. As soon as we realize this, the question is solved. As soon as we realize. So let us solve it here. Solution. First of all, I will find the magnification. We all know the formula for magnification. Tell me fatapat. How much is the magnification coming? This is the question of JEE Advanced.
Minus 15/2 meter per second.
Huh?
Centimeter per second.
Huh? It's an integer type. Minus 15/2 is not possible. Tell me the formula for magnification first.
Velocity of mirror,
F
sir.
by F minus U, sir.
Tell me the answer, sir, for magnification.
F by F minus U, sir.
Arey, answer, sir.
Minus 1 by 2.
Chalo, sir. One thing is done.
Minus
sir.
1/2.
So, now I have velocity of image with respect to mirror, and velocity of image with respect to mirror is velocity of image minus velocity of mirror. Do we understand this? Please raise your hands. That yes, sir, we understand this. We understand this or not? Arey, say yes or no.
Sir.
Okay, that will be equal to minus of minus 1/2 ka square. What is the square of minus 1/2? 1/4. Yes or no?
Yes, sir.
Into velocity of the object with respect to the mirror. What is the velocity of object with respect to the mirror? VO minus VM. Do we understand this? Yes or no? No, yes. So far, so good? Can I have raised hand from everyone in the class? So far, so good, sir. Now, so far, so good, sir. Arey, sir, what's happening, sir? Now, the rest of the problem, can you do on your own and tell me the value of VM? And see, I have not done anything extravagant. What is the value of VI, velocity of the image? It is given in the question. Yes or no?
Yes, sir.
How much is the velocity of the image, bacha? It is with respect to ground, with this laboratory. How much?
Yes, sir.
Say. Arey, say.
0, sir.
0, sir. Yes, sir. Tell me the value of VM, sir. I cannot solve this for you, sir, because if I solve this one also for you, sir, you will get andas in the exam, sir. Tell me the value of VM.
15/2, sir.
That is not correct, sir. (15/2), okay. Let us solve it. 1/4. See, sir. Carefully, sir. So, what will you get? Let me solve it. I think you are having problems in solving it. So, what will I have? This
Sir.
my. Yes, sir.
Answer is 3, sir.
Answer is 3, sir. That is what I got from the JEE Advanced ka website, sir. That the answer is 3, sir. And thank God, sir. God still remains in this universe, sir. That you also got the answer 3, sir. That is the answer, my dear friends. As you can see, this question could have been done. See how shortly I have done this. This much. I could have even cut one more step from this question. And if you are smart enough, you could have calculated this value in your head. Yes or no? You could have calculated this value in your head. You should have calculated this value in your head. Then the only thing you had to do was put this formula and solve this equation. You could have done this in 45 seconds. A good student will do this in 45 seconds and he will be in the top 10 or top 100 of the country. See, so simple questions are asked in JEE. Do you understand this? Was it tough? Say yes or no. Sir, it was very tough. We could not solve it, sir. Very, very tough. So tough. We got scared looking at the question, sir. Is that so?
No, sir.
See, everything depends on how you look at it. A good student who has solved this in the class could have done this in 45 seconds. And then you can imagine how much time you could have saved for the other questions. So, what I say is, JEE is a test of your speed. And JEE is not cleared in the examination hall, it is cleared in the class. Because if you start to calculate first the value of V, you will take some time to calculate the value of V. And if you do a mistake there, then everything...
Sir?
Yes.
How VI is 0, sir?
How VI is 0, sir? Who will tell the answer of this thing, sir? Anyone?
Image
Girls?
is at rest. Image is at rest.
Girls? Anyone speak up loudly? I just can't hear you. Yes? Anyone?
Image is rest with respect to elaborate frame.
Such that the image is instantaneously at rest with respect to the laboratory. Remember, beta, you will only get one chance to read the question in the examination hall. If you read the same question 4 times, my dear friend, that means you have lost the time of 4 questions in 1 question. And you are done. You might be solving that question, but you have lost 4 questions. And losing 1 question means from IIT Mumbai, you fall to IIT Hyderabad. That doesn't mean that IIT Hyderabad is bad. You lose 1 more question from IIT Hyderabad, you go to some IIT which I even don't know the name about. Mandi, maybe. And you drop 1 more question, my dear friend. IIT is gone. And we are floating somewhere here. Got it? Every question matters. You lose 4 marks, my dear friend. You lose as many as 3,000 to 4,000 ranks. Cut out of your thing. And you lose 4,000 ranks, you are done. So remember, please, even if you do only those questions that I have done in the paper, in the examination hall, in the class, you should be able to clear JEE. And when I say JEE, I don't mean JEE Main. I do not consider JEE Main as an exam. JEE Main is a waste of time. It's a speed of your, no, it's a test of your speed. You can do it fast. This question will never come in JEE Main. Still, you can solve it in 45 seconds. And I will show you each and every question from this year's paper. And I'll prove it to you that this question could have been done in 45 or 50 seconds or 1 minute. Except from 1 or 2 questions. And no one got 100% right in this year's paper. In fact, this year's paper was the lowest percentile ever in JEE for the past 20 years. So, practice hard and practice. Get your speeds up. Do you understand? I keep on telling you, remember.
sir.
If you remember this, you can do it fast. If you don't remember it, you'll lose time. Hello, on that note, your reflection is done. And in the next class, we shall move on to refraction. And we will do another question from JEE of this year. And you will see that question can be done in a matter of seconds. I'll see you in the next class. Take care. May God
Bye, sir.
bless you all.
Hi, sir.